So here we are given that y is equals to x plus square root of x squared plus 1 whole raised to the power of m. Using this value, we have to show that this particular expression is true. So let's begin. We have y equals to x plus square root of x squared plus 1 whole raised to the power of m. So let's call it equation number 1. Now what we'll do, we'll take the derivative on both sides with respect to x. So we have derivative of y with respect to x. Now what we'll do, we'll have to use the power rule here. So we have m times x plus square root of x squared plus 1 whole raised to the power of m minus 1 times, we'll have to also use the chain rule here. So we'll take the derivative with respect to x of x plus square root of x squared plus 1. Fine. So this gives us m times x plus square root of x squared plus 1 whole thing raised to the power of m minus 1 multiplied to, now we'll take the derivative of each of the terms. So we have derivative of x, which is simply 1, plus derivative with respect to x of x squared plus 1 whole raised to the power of half. This is done so that we can easily apply the power rule here. Now we will have m times x plus square root of x squared plus 1 whole raised to the power of m minus 1. So this will be multiplied to 1 plus half times x squared plus 1 raised to the power of half minus 1, which is negative half, times now derivative of x squared plus 1, which is simply 2x plus 0. Fine. So our derivative is now done. So here 2 and this 2 will get cancelled away. Now that gives us m times x plus square root of x squared plus 1 whole thing raised to the power of m minus 1 multiplied to 1 plus x divided by square root of x squared plus 1. So here we have taken x squared plus 1 raised to the power of negative half to the denominator and converted the exponent to its radical form. Now we will add these two terms. So that means we have derivative of y with respect to x. So this will be equals to m times x plus square root of x squared plus 1 whole thing raised to the power of m minus 1. And when we add the two terms, we have square root of x squared plus 1 plus x divided by square root of x squared plus 1. Now you can see that these expression x plus square root of x squared plus 1 raised to the power of m minus 1 is multiplied to x plus square root of x squared plus 1. So when we combine these two terms, that's going to give us m times x plus square root of x squared plus 1 whole raised to the power of m minus 1 plus 1, the whole thing divided by square root of x squared plus 1. So this is dy over dx. So here negative 1 and positive 1 gets cancelled out, and that leaves us with dy over dx equals to m multiplied to x plus square root of x squared plus 1 whole raised to the power of m divided by square root of x squared plus 1. Now this is actually y, which was already provided to us, which we can replace it with. Now we'll get dy over dx equals to m multiplied to y divided by square root of x squared plus 1. So this is now further simplified. Now we'll cross multiply it to get square root of x squared plus 1. So this will get multiplied to derivative of y with respect to x. So that's equals to m times y. Fine. Now let's square both sides. So squaring both sides is going to give us x squared plus 1 multiplied to dy over dx whole squared. So this will be equals to m squared times y squared. Now we'll replace dy over dx with the notation. Since it's the first derivative of y with respect to x, so we can simply replace it with y1. So that means our expression is now x squared plus 1 multiplied to y1 squared. That's equals to m squared times y squared. So we'll take this expression and then we are going to take the derivative on both sides with respect to x. So let's take it. So we have derivative with respect to x of x squared plus 1 multiplied to y1 squared. So this will be equals to, so here m squared is a constant, so we'll simply multiply it with derivative with respect to x of y squared. Fine. So here we'll have to use the product rule. So we have x squared plus 1. So that will be multiplied to derivative with respect to x of y1 squared plus y1 squared is multiplied to derivative with respect to x of x squared plus 1, which will be equals to m squared times, we have derivative of y squared, which is simply 2y times derivative of y with respect to x. Right. So this gives us x squared plus 1 times, so we have to take derivative of y1 squared, which is 2 times y1 multiplied to derivative of y1 with respect to x plus y1 squared times derivative of x squared plus 1 with respect to x. So that's simply 2x. And this is equals to m squared plus 2y times derivative of y with respect to x. So that's y1. Now we get x squared plus 1 multiplied to 2 times y1 multiplied to, so this is the derivative of y1 with respect to x, which gives us the second derivative of y, or simply y2, plus 2x times y1 squared, and that's equals to 2m times y times y1. Now what we'll do, now we have y1, so we'll take 2y1 as the common factor, so that gives us x squared plus 1 multiplied to y2 plus x y1, which is equals to 2y1 times m times y. Now we know that the first derivative of y with respect to x cannot be equals to 0. So this means that x squared plus 1 times y2 plus x times y1 equals to m times y. Here we have m squared. Is the m squared, so this is m squared equals to m squared times y, and if we bring m squared times y to the left hand side, we'll get x squared plus 1 times y2 plus x times y1 minus m squared times y equals to 0, and this was what we were asked to prove. So let's check that out.